Okay, so I have forgotten to actually press the recording button, so let's just review a little bit. So we studied about trigonometric identities. I told you that that's an important lesson, so let us continue with some exercises. All the exercises that you see here, probably except the first one, are a little bit higher than the level of the book, so you will not expect such a question probably in the exam, so you shouldn't be worried about that. Especially those kind of exercises are missing in the book, usually. Okay, and I told you that in other books these are also very ubiquitous. You can find them in trigonometric books. Cotangent is 1 over tangent, which of course means cosine divided by sine, because tangent is sine divided by cosine, so cotangent would be cosine divided by sine. And secant is 1 over cosine, and cosecant with this symbol is 1 over sine of x. So I don't know, I want to present my own method. This is probably not the only way, so if you are completely sure about the way that you have solved the problem, that's okay, but if you have doubts, you can ask me, okay? So if I want to solve this, usually I start from the side which is more complicated and try to simplify it and to reach to the other side, yes? For example, it is very clear that for this case, number 1, I should start from the left-hand side, yes? So number 1, so let me write the solutions here. So do you have any suggestions for me? How did you do it? One of you, for example. Yes, Dylan, how did you do that?
The conjugate pattern.
The conjugate pattern is probably the best one. Of course, you can start multiplying them term by term, but I hope that you immediately realize that you can give the role of this A to this guy, and then this becomes exactly A itself, and then you can call this B, and then this becomes B. Then what you have A plus B times A minus B, which is the very simple pattern of conjugate identity. So it becomes A squared, so the left-hand side, by that explanation, becomes A squared to the power of 2 minus the second one to the power of 2. But then I can use the squaring rule to expand this. It becomes the first one to the 2, 2 times the first one times the second one, and the second one to the power of 2. What I have written is the expansion of this pair of brackets, and then I have minus 1 to power 2, which is 1. But then hopefully you immediately, at this level, can detect that this is the famous pattern. So cosine squared of the angle plus sine squared of the same angle becomes 1. So this becomes 1, and then you have a minus sign, minus 1 there, so they cancel, and what is left for you is what of course in the exam it's better to write it down. So it becomes 1 plus 2 sine x cosine x, and then you have minus 1, and then you know that this minus 1 and that 1 cancel, so you are left with this one. But that's also a famous combination in trigonometry, and that probably, if you have forgotten, you can just review it on the formula sheet, and the answer would be sine 2x. That is actually the double angle formula for sine, and then you reach to the right hand side. So it was very actually simple. Any questions here? No? Understandable for everyone? Okay, let us carry on to the second one. Of course, you shouldn't be uncomfortable with this one, because cotangent is 1 over tangent, or if you want, it is cosine over sine. So what is your suggestion for solving this problem? Yes, Dylan?
Since the right-hand side involves sine and cosine, I get the idea that you can change tangent to involve sine and cosine.
Yes.
So you get...
And then, for cotangent?
You just flip it. So
yeah, cosine over sine, and then try to multiply them. Yes, that's correct. Yes. But for example, might be that's also another way. So the way that Dylan actually explained is completely reasonable, because by looking on the left-hand side, you see that you have sine and cosine, but of course you have also tangent and cotangent involved. But on the right-hand side, you don't see any track of tangent and cotangent, so this motivates you to get rid of these things in favor of sine and cosine. But that's completely natural. But when I was thinking right now, I found a better way probably. So what you can do, I have 4 numbers that I want to multiply. Yes. So it doesn't matter in which order I multiply them and in which group I multiply them. So I decided to multiply this by that and then this by this. Let us see what happens, yes? So the left-hand side becomes equal to... So is that understandable? First of all, I am allowed to do this because I am multiplying 4 numbers. So it doesn't matter which one I multiply, find the answer, and then multiply the answer by the other one. Is that, first of all, understandable for everyone? This is valid. So if I want to multiply 2 times 3 times 4 times 5, I can multiply 2 by 3, 6, 6 by 4, I don't know, 24 times 5 is 120. But you can also multiply this by that, 10. You can multiply this by that, 12, and then multiply 10 by 12, it becomes again 120. So it doesn't matter how do you actually group them and multiply them. So the reason that I have decided suddenly multiply this one by the last one is clear, isn't it? Because what happens here, I will actually, I don't know how to write it down. So I multiply this one first here. So it becomes cosine theta plus cosine theta tangent theta, yes? And then what can I do for the last one? It becomes sine theta plus sine theta cotangent theta, yes? So what's the answer now? So instead of cosine theta, let us keep it. But can you tell me what can I write for this combination? I am multiplying cosine by tangent. The answer is sine theta. Is that understandable for everyone? Because tangent is sine over cosine. When I multiply it by cosine, cosine is gone, and I am left with sine. Okay, what can you say about the other one? I would write it sine theta, and then what happens here? Cotangent is the flip of tangent, so it is cosine over sine. So the answer is
Cosine theta.
cosine theta. Is understandable or not? But these two are the same. So if you multiply something by itself, it becomes that thing to power 2, and that's exactly what you want to show, yes? And that's equal to the right hand side. Yeah, but what Dilan explained is actually essentially the same thing. Yes, but we did it in a different way. Is the solution understandable for everyone? But I told you that's not the only way of solving it. If you're just solving it by multiplication, that's completely okay. These I consider a good problem. Especially, of course, multiplication isn't hard, but it is not evident how, because on the left-hand side, you have just sine and cosine involved of the angle theta, but suddenly on the right-hand side, cotangent of 2 times that angle is coming in. Yes? So it is not that clear what we are supposed to do. There are 2 ways. Either we should give up, or we should do something, yes? So we choose to do something. Okay, so what we are supposed to do, can you tell me, so at least you can have some idea what to do. So what should I do? What do you think is a reasonable starting point? Because it is not clear exactly what I'm supposed to do. But I have to do something if I want to solve the problem. Yes? Any suggestion? Yes?
You start from the right hand side.
Why? By the right hand side?
Yeah.
Okay, so the right, okay, then what do you want to write for the right hand side?
Because then you can, like, using the double angle formula, you can just get
Yeah,
that.
that's a
You can
good
involve
idea.
sine
I haven't thought it in that way, but might be it works.
It worked. So,
You solved that?
yeah.
Okay, so let me just, do you want to solve it here?
No.
Okay. So let me follow yours. Okay, so you are saying for number 3, you start from the right hand side. Okay, and he says that, okay, let me write everything here. So 2 cotangent to theta. Okay, so what happens is that 2, instead of cotangent to theta, what should I write? Cosine of that angle divided by sine of that angle. Yes. So first of all, is that understandable for everyone? Yes. Okay, then what?
And then you substitute cosine 2 theta with the double angle, so cosine...
Which one? There are 3 alternatives.
Yeah, and cosine squared minus sine squared.
Yes, that's probably the best choice here. So do you remember, if you look at the formula sheet, for sine 2 theta, let me write 2 here, multiplied by. For the denominator, I have 1 alternative. Do you want me to use that?
Yes.
Yes, so it becomes 2 sine theta cosine theta. So that is the only alternative for the denominator if I want to expand it. But in the numerator, there are three alternatives, and Dylan is actually saying that let us choose the first one. If you go and look at the formulas, it becomes cosine squared theta minus sine squared theta. Okay. Then can you tell me what to do?
I factorize 1/2 out.
So these 2 and 2 are gone actually.
Yeah.
Yes, don't factorize. So these 2 and 2 are gone. Then I am left here and there. Then what should I do? How should I continue then?
Yeah, the thing that I did was I got to that point, and then
Yeah.
I simplified the left hand side, and then I compared the factors.
Yeah, that's also correct. So that's actually very, very good. Yes.
But I think that you can continue. I don't know.
Yeah, we can stop here if you want to do it in that way. It's okay. I want to show that it is completely valid way of solving the problem. Yes, thank you very much. So I will follow yours. So the left hand side, now he decided. So let me write this here. So this implies that the right hand side is equal to cosine squared theta minus sine squared theta, and then you have sine theta cosine theta. So let us put this in a box now. So this is what I get for the right hand side. And now I follow your strategy. So you are saying that let us multiply the left hand side, yes? So how should I multiply the left hand side? Term by term, yes? So I need to multiply this by that. So you can do it in your head. Sine theta times 1 over sine theta is 1, yes? And then sine theta multiplied by that is what? Minus sine theta over cosine theta. Yes? And then you come here, multiply this by that, it becomes plus cosine theta over sine theta. And then you multiply this by that, it becomes negative 1. Yes? Yes, understandable for everyone? Okay, and then you see what happens. This one and this one are actually gone. And let me write them in order nicely. So it becomes cosine theta, sine theta. I write this one with the positive sign first. Yes, because I'm an optimistic person. Okay, so then it comes here. And then what should you do? You take the common denominator. I told you that. Here, most of the time in trigonometry, the common denominator is just simply the multiplication of them. So this becomes sine theta, cosine theta. And then do you know that? You divide this in your head by that one, it becomes cosine theta. You multiply that factor by the numerator, which is coincidentally cosine theta. It becomes cosine theta to power 2. And the same story for that one, it becomes minus sine squared theta. Yeah, that's completely valid. Thank you, Dylan. So let me write this. So this would then imply that this left-hand side is equal to that. And I think if you want to write it properly in the exam, it would be good to say that this is number 1, this is number 2. Then I would say that from number 1 and number 2, I can conclude that the left-hand side is equal to the right-hand side. Yes? And so thank you very much. So I will actually follow yours. It is a good way of solving. Yes? Louder, please.
Can you also try to calculate with the codes?
Can I what?
Can you also calculate with the codes?
I don't understand your question. Here, for the number 3, you mean?
Yeah.
What should I do?
Like instead of writing cos x, cos theta out of sin, you can write 1 out of tan x, okay, and then you write cos x instead.
So what I understand, what you are saying, that I should write cotangent of theta here, and then this would be minus tangent theta. Yes, it is correct, but if you write it, then what? So because you know that I do not want just to random things. If you write cotangent theta minus tangent theta, it's correct. But how can I compare it with what I got here? Or might be you have another idea.
Yeah, because I didn't choose the long way.
Okay.
I didn't
So you start a different way from the beginning. So you started multiplying in?
Yeah.
Okay, so let us follow yours as well. So what you are doing is correct. So that's also correct. If you multiply this by that, it becomes 1, and then this becomes minus tangent theta, and then it becomes plus cotangent theta. Yes, but you have to continue in some way to reach to this. Then what is your idea here? Yeah. Now, this is not wrong. This is, if you write the left-hand side is equal to this, that's 100% correct. But the point of identities is not just writing something which is correct. You have to follow what you are supposed to find. So you need to find a way, choose that correct path that takes you to exactly your destination. Yes, but if you write this one is equal to this, is 100% right. Yeah, but it is not that useful in this problem. Just sooner or later you have to replace tangent and cotangent for sine and cosine again. Unless you have a formula in mind that cotangent theta minus tangent theta is 2 cotangent 2 theta, which I have in mind. I knew that this would be the case. Yes, but if you don't know, you have to prove it. Okay, so what do you think about number 4 then? Number 4 is a little bit combination. I just put this here intentionally to remind you a little bit about what we have studied already, yes? So how should I do that? Do you have any hope? Is anyone solve the problem? Does anyone solve the problem?
I didn't get
Exactly, yes. But for example, can you just share your ideas with us? So what do you think it would be suitable for solving this problem? Yes?
I think we can get the common denominator between the two first terms. So
Is it useful?
I'm not sure yet. But,
Yeah, but because I'm a little bit lazy, I will not go for it because I do not see any. So you are saying that first of all this is multiplied in the numerator, yes?
no, I don't mean like that.
And then of course you take the common denominator between these two.
Yeah.
And then this will go here, this will be multiplied here. So then what happens if you take the common denominator? The common denominator would be the product of these two.
No, I mean like sine 900 minus theta.
Uh-huh.
You can just subtract 2.
So that's not common. You said common denominator.
Yeah, it becomes the common denominator if you do that.
Okay, so that's what you are saying is that let us work on these things individually somehow. Yeah, that is the correct idea. Yes? So if I want to do this, for example, if you don't mind, let's start from here. So if I want, you want to start from here?
Yeah.
Yes, let us start from
No,
here.
no.
I don't want to disappoint you, but let us start from there. Okay. So sine 900. So what is Dylan actually saying is completely true. First of all, let me say something that I remember that I could have taught you when I was teaching the subtraction formula. Here, can I use subtraction formula? Because that's a subtraction formula. Sine 900 minus theta. If you don't remember the formula, I can remind you. It becomes the sine of the first one, cosine of the second one, minus the other way around. So that is definitely true. So you can use it if you want to. But the problem is something that you don't know, probably sine of 900 and cosine of 900. So you can focus on finding sine 900 and cosine 900, which is not that hard. Yes?
Isn't sine 900 minus theta sine 180?
Yes.
So it's easy to find out.
Yes, yes. That's what I'm saying. I just want to give you an alternative. Because I remember when I was teaching, so do you remember, let me just review a little bit. Do you remember we solved this problem, for example, under the title of Supplementary Angle Theorems. When I was teaching that topic, we didn't know about this subtraction formulas. It was, I don't know, at least a little bit negligence from my side that I should have reminded you. If you want now, you can use the subtraction formula. Sometimes it is easier. Do I need subtraction formula to make sure what is the connection between theta and sine theta? No, because you can go and think very elementary. You can say that, okay, if theta is this angle, 180 minus theta, hopefully everyone knows that this would be 180 minus theta, yes? And then sines are the y values. So what are the y values of these final points? They are exactly the same. So you realize that this has to be equal to sine theta. Do you remember these kinds of symmetry arguments? But if at this level, if you want to, you can also use the subtraction formula. What you write sine 180, sine of the first one times cosine of the second one, minus sine of the second one multiplied by the cosine of the first one. So if you want to, you can write this one now. But then I ask you, what is sine of 180? You can imagine it. 180 is here. What is the y coordinate? 0. And 0 times cosine theta, so that's completely gone. And where is 180? It is here. Cosine is the x coordinate. So what is the x coordinate here? Minus 1. And you multiply minus 1 by minus sine theta, you get your sine theta back. So now you have two methods for solving these problems. One, addition or subtraction formulas, and one, symmetry arguments. So what you said was based probably on symmetry argument, yes? 900 minus theta will end up the same point as 180 minus theta, yes? Yeah. So let us follow that method. So where is 900? So 900 means that if I go up to here, it's 180. If I go 5 times 180, it becomes 900, yes? Agree? 5 times 180 is 900. So it's 1 times, 2 times, 3 times, 4 times, and 5 times. I will end up exactly here. So this is 900. So 900 minus theta would be exactly here. So what is its connection with theta? They are equal. And you can do better than that. So you can just immediately write this guy is sine theta. Yes, you don't need to write sine 180 minus theta and then write it is equal to sine theta. Is that understandable? So what I have done, I tried to find the final point for this angle. If this angle is theta, we realize 900 after going around several times, I will end up here, but then 900 minus theta will be exactly here, theta before that. But then you immediately realize that these have the same y coordinates, so sine of this angle is nothing except sine theta. Yes? Clear? Okay. So we actually simplified this guy a lot. So let us talk a little bit about the denominator here. So sine of, what do you think about this? So symmetry argument, let us follow symmetry arguments. Because in this case, if I want to use a subtraction formula, then sooner or later, I have to calculate sine of, I have to use the symmetry arguments at the end of the day, because I have to know what is sine of 630, I have to know what is cosine of 630. So where is this angle located? What is that? So if I go to one full round, it is 360. When I go up to here, 180 more, it becomes 540. Yes? And if I go 90 more, it becomes exactly 630. Is that understandable? So let us, 630 is 7 times 90, yes? So it means that 190, 2, 3, 4, 5, 6, 7. So I end up here. Yes? And now minus theta. So if this is theta, so this angle from here, so this would be the final point. Because if I just go around 630 degrees, I will end up here. But then I want to have minus theta. So sorry, this is a little bit tricky. So I need to wait, so I need to stop theta degrees before that. Yes? But can you tell me what is now, how this one is related to that? Let me make it a little bit bigger. So here is the circle. So if I go 630, I hope that I could convince you, you will end up finally here, yes? But you have to stop theta before that, theta degrees before that. So I have to end up somewhere here. For example, assume that this is theta. If I ask you where is the final point for this angle, you will show me this, yes? And now how this is related to the sine or cosine of this angle. So what I have to do, I have to draw this angle because this is not the origin of angles. The origin of angles is here.
So then I have to make this a theta angle here. Yes? And then if this is the x and y coordinates, okay, can you tell me what are the coordinates here? It is not symmetric here. So it's a symmetry and flipping things, yes?
Y minus y.
Yes. So the coordinates here are minus y and minus x. Yes? Why is that? Because this is, from length point of view, this is x. But because of symmetry argument, this length is equal to that length. If this is x, this one is x in the opposite direction. So the y coordinate, so this is the y coordinate of this point. It's minus x, and for the same reason, this would be minus y. Is that understandable? Whenever they are related to 90 degrees, you have to have this flip of coordinates. Is that understandable for everyone? Because this triangle and that triangle are congruent because of symmetry arguments. So this length is the same length as here, and this length is the same length as here. So if I ask you what is this length, you would say the length is x, because that is the x coordinate of this point, and this is y. So from length point of view, this line is y units, okay? But it is in the opposite direction, so it becomes minus y. But that would be the x coordinate of this point, because this is the x coordinate of this point. So this is why I wrote it here. And for the same reason, I write minus x here. Now, finally, can you tell me what can I write in front of this? Sine of 630 minus theta is the y coordinate. So it is minus x. Yes? But minus x is minus cosine theta. Yes? Is that understandable? Okay, if you find it a little bit difficult, let me use the addition and subtraction formulas. So if you want to do that, you can write sine 630 times cosine theta minus sine theta times cosine 630. Might be you really don't need any symmetry arguments if you use addition or subtraction formulas, okay? If you are confused a little bit, if the symmetry argument sometimes becomes hard for you, you can use this idea because you have the formulas in the formula sheet. But what you need to do is to understand what is sine of 630, but this is easy. Why? Because where is 630? Agree with me, 630 is here. And then I ask you, sine is the y coordinate. What is the y coordinate? What is the y coordinate of this point? Minus 1. So this is nothing except minus 1. And if I ask you what is this one, that is the x coordinate. The x coordinate is? No, the x coordinate. It's 0. So then you see that 0 times this is totally gone. And minus 1 times cosine theta is exactly what I have written here. So this is completely algebraic. I just wrote the formula. But here you need to think geometrically. It doesn't matter which way you do it. Yes, is that clear? So anyway, the final result is that this guy is minus cosine theta. Yes or no? Yes? Okay, so what can I write about sine of 270 minus theta? So what can I write here? I hope that you can convince. This is not a hard problem. So if you use this method, this is very straightforward. So it becomes sine of 270. What is sine of 270? It's the y coordinate of 270. This would be 270. Yes? And then sine is minus 1. You multiply it by cosine, so it becomes minus cosine theta, minus the other way around. But the other way around, cosine 270 is 0, so I don't need to write anything. So that would be the answer. Yes? And then I have to calculate tangent of this one. But tangent, you do not have any formula for tangent. Either you have to use the symmetry argument, or you can use sine divided by cosine idea. Yes? So tangent of 270 plus theta, it it becomes sine 270 plus theta divided by cosine 270 plus theta. Okay, now can you, I don't know, it might be you don't have the formulas in your head, but symmetry argument is working, but if you want to use this, I have the formulas. You can also have the formula in front of you in the formula sheet. So you can say that sine of the first one times cosine of the second one. But sine of 270 is minus 1. So it becomes minus sine theta plus the other way around. But the other way around becomes 0 because cosine of 270 is 0. So you don't have anything else. And then divided by cosine of 270 plus theta, it becomes cosine of the first one times cosine of the second one, but cosine of the first one is 0, so it is gone, minus sine of the first one, sine of the second one. But sine of 270 is minus 1, so it becomes cosine theta. Yes. So if you want to, you can write it minus tangent. So in principle, you should be able to find this formula directly using symmetry arguments. Okay, so that was just a review. Might be that was not a very interesting problem, but it's just a review so that I make sure that you haven't forgotten totally everything. So let me now start doing it from the left-hand side. So I start from the left-hand side. Instead of 1 over sine 270 minus theta, what is that one? It's here. Oh no, where is it? It's minus cosine theta. So it becomes minus 1 over cosine theta. So let me just... Okay, so it's minus cosine theta. And if you see it here, the next one is sine of 900 plus sine of theta. And then divided by the denominator is sine of 630 minus theta. But we got minus cosine theta there. And then multiplied by minus tangent of theta, the last one. But because everything is expressed in sine and theta, if you don't mind sine and cosine, let me write this formula instead. So let me wait a little bit. Are you following what's happening? So I actually calculated or simplified each term. I replaced those with simplified versions. And then I want to ask myself, can I simplify and finally prove the problem? I don't think it should be very hard, is it? So what can I do here? This is a very simple one. So I have to copy and paste probably the first term. But what can I do? This minus sign and that minus sign will go away, and then sine becomes sine squared. So it becomes plus sine squared divided by cosine squared. This is a little bit strange, isn't it? Can we really reach to that point, cosine theta? 1 minus 1 cosine theta. Have I made any mistakes or not?
Just switch sine squared theta over cosine squared theta is 1. And then
No, it's not 1. Sine squared over cosine squared is not, unfortunately, 1. So might let me think. So it's minus cosine squared, so it becomes minus 1. I have to check that if I have written the question correctly. Because what I have, let me double check. So that was, yes, that's correct. That one is also correct. That one is also correct. And tangent is also, no, I made a mistake. It cannot be tangent. Because I know from symmetry argument, tangent of 270 should be related to cotangent. This is the mistake. Could you detect my mistake? Yes, my mistake is coming from here. So you see, I know that whenever 270, whenever these points are involved, sine should change to cosine and tangent should change to cotangent somehow. So I made a mistake in this calculation, and probably because I did it fast without writing, you shouldn't detect that. So let me just repeat this. Sine of the sum of two angles is the sine of the first one, which is -1, times cosine of the second one. So it is cosine theta. Plus the other way around, but I don't need to be worried about the other way around because cosine 270 is 0. And I made the same mistake here, just copy and paste things. So it becomes cosine of the first one, which is 0, times cosine of the second one, which becomes 0, plus sine of the first one, times sine, minus, so let me write it here. Cosine 270 plus theta is cosine of the first one, cosine of the second one. But because this is positive and this is cosine, I have to write minus sine of the first one, sine of the second one. So that was my mistake, sorry. But cosine of 270 is 0, but sine of 270 is -1. There is also another minus sign here, so it becomes positive sine theta. So that was my mistake. Oh, sorry for that. And this is not tangent. Let us stop here. I don't need this. And when I put it back here, this is minus cosine theta, and this is sine theta. Yes? And now everything should work. Because now you see it works actually, it is done. Because sine theta and sine theta are now cancelled. Minus cosine theta and minus cosine theta are cancelled. So this is nothing except 1. Okay? And then I have -1 over cosine theta. So it is 1 minus 1 over cosine theta. Okay, sorry. That was very backwards. Okay, any questions here? Yes, hopefully I didn't confuse you. Okay, so these are the normal trigonometric identities, but some trigonometric identities which are actually a little bit higher level are conditional ones. So I cannot, for example, I am not in this exercise, I am not asking you to show that without any assumptions. I am asking you, show the truth of this if the truth of this is guaranteed. So this is different. You see here, I have asked you to show this equality without any assumptions, except the assumptions that you have is just trigonometric and your mathematical knowledge. But here, I haven't asked you to start from the left-hand side with bare hands and reach to the right-hand side. I am giving you an extra piece of information. I am giving you this fact if, there's a big if for that. If this is true, show that this one is also true. Okay, so this is a little bit new exercise. I just want you to get familiar with this. This is one of the problems that actually I uploaded for interested students, but let me just solve it here for you as well. So, do you have any idea how to solve this problem? Let me clean everything so that you don't see any distraction in front of you. So we want to start from the left-hand side, of course, and reach to the right-hand side, but you need to understand where, if suitable, to use this condition, or any other way that you think you can prove this. Yeah, this is one of those problems for interested students, but I think hopefully you are interested, aren't you? So what do you think? Let me just write things in front of you. So I know that. How I know? I don't know myself. The person who has designed the question says that if this is true, you need to prove that this one is also true. So it means that I can write it in this way. I can put an arrow here with question mark. From here, and my mathematical knowledge, I should want to show that this is also true.
Do you have any idea how to do that? Yeah, I know that this is a little bit a non-standard problem for you, but let us try to think. By the way, there is a mathematical competition. Who is interested to join next Tuesday? Yes? Yeah, I hope that at least some of you join. It doesn't happen anything. So the questions are hard, even I myself cannot solve sometimes. So, but you don't need to be worried. This is the, I wanted to do the semi-introduction, but it took a lot of time from us. But anyway, please, if you are interested, it doesn't matter for you. You just sit down and see the questions. That would be an experience for you, and just leave the session. The exam is 5 hours, of course. Yes. But you don't have to be there for 5 hours. If some of you are going to join, then of course I promise you I will not teach that Tuesday. I just give practice session to others so that they can practice. I really want you to join, okay? Of course, there are a limitation. We are not allowed to take in more than 15 students. Some of the technique, 20 students are actually joining. And of course, if you also want to join, you are very welcome. Yes? And if you want, I can give you more information after that. So I think about it next Tuesday, because we want to arrange this exam. If there are no volunteers, that's cancelled. But even if you have, I don't know, 2 or 3 volunteers, might be we can set up a room so that you can be with the guardian and then you can do the exam. At least you can fill the questions. And of course, you don't need to start with the bare hands. I give you information. But let us, for example, this is one of those type of problems. So that you can consider it as a contest problem. Something like this. It's non-standard, yes?
Can you square
This is a good idea, but I will not go for it. The reason that you are interested in squaring is probably because of seeing sine to the 4 and cosine to the 4. It's very good. So this way of thinking I want you to learn. But when I raise it to power 2, what happens before doing it? This becomes this 1 to power 2. It gives you a squared sine to the 4x plus the second one squared 2 times the first one times the second one. And when I multiply, first of all, when I square it, I get sine to the 4 that I like to, but unfortunately I get a to the power of 2, and you see that a to the power of 2 is not there. This is one reason I will not go for it, even though it was reasonable in the first place. And the second one is that I have 2 times the first one times the second one, which becomes sine squared, cosine squared involved. So probably it was a natural step to think about, but I will not go for it. Of course, you might go for it and find a way. Yes? But I will not, okay? Yes?
I'm not sure, but if you take 8 times sine squared of x,
Yeah.
equals to 8. Can't you think that
Is it equal to a?
No, like it writes a sine squared x
Yes.
minus b times cosine
Yeah.
squared x
Yeah.
equals 8 minus b.
Yes?
So if a times sine squared of x,
Yes?
can't you say that sine squared of x equals to 1?
No. If sine squared is equal to 1, that's one possibility. But if you want to say that this implies that sine squared is equal to 1, you have to actually show that. Any other ideas? So this is the nature of contest problems. When I solve this problem, I'm 100% sure all of you will understand. But the point is that, can you find the idea yourself? So that is the nature of those kinds of problems that could be extremely hard. So let me just give you some guide. So here, if I want, my goal is to prove this. I need to start from one side, try to reach to the other side. Don't lose the logic. If you start from the left-hand side, go to the right-hand side, you need to get rid of what? You see, I am using the same idea. I want to go from the left-hand side to the right-hand side. I look at the right-hand side to see if I can find a pattern or something. I immediately realize that I should do something. What should I do?
remove sine and cosine.
Remove sine and cosine in favor of A and B. So this is your strategy you have to start fighting for. Because if you do not have a strategy, just random calculation doesn't work in mathematics. Yes? And it wastes your time. So now we have a strategy. It might not be very clear how should I do that, but the strategy is to get rid of sine of x and cos. I need to get rid of variable x. Because variable x is not on the right hand side. So I have to get rid of variable x. So now I have my strategy. So now I need to give energy to this strategy if I can find a solution to that. Now I need to go back here. Do you understand how should I do to get rid of x or sine x or cosine x? It's not straightforward. You cannot do it, as I see, you cannot do it in one step. But you need to do it gradually. Okay, so let me, because we don't have time. For example, let me give you a hint. So I will write a sine squared x minus b. Instead of cosine squared, I can write this. Yes? Every one of you probably knows about this at this stage. So that's what I'm saying. The problems in mathematics becomes hard. It means that you need to be able to connect the ideas together. Do you think this is useful? It should be. Why? Because my goal is to get rid of x. This gives me only one unknown, and the unknown is sine x. So I can find sine x in terms of a and b. How? Let us see. I multiply that. It becomes minus b plus b sine squared, agree, is equal to a minus b. First of all, minus b, I move it to the right hand side, so this is gone. So very good. And then what happens, I have a common factor here, I factor it out. Yes? And then I calculate sine squared from here because I am following my strategy. My strategy is to eliminate x in favor of a and b, and I did it for sine. Yes? Sine squared becomes, so you need to take lessons. If you want to be a good problem solver, you need to take lessons about why I couldn't find the idea. And try to think a little bit, few minutes, so that it will go to your memory actually. So now, is it a good thing? Yes, my goal was to be able to eliminate x in favor of a and b. I couldn't eliminate x, but I could eliminate sine squared, better than that even. Yes? So, but what I need here, I need sine to the power of 4. So what I do now I square. So now you see, it was practically not possible there, but still the idea was not useless. It is useful, but at this stage. Yes? So I raise it to power 2. It becomes this. It becomes a squared divided by a plus b to the power of 2. Yes or no? And then, now can you tell me what should I do now? Yes?
Cosine 4 to the power 4x is 1 minus a to the power 2.
No, you need to prove that again.
Okay, you can.
So you need to go back again, but you changed your methodology, yes? Instead of eliminating cosine, you can eliminate sine. Yes? Or, by the way, you can do it a little bit differently. You can go and start from here, or you can say that cosine squared, I know what cosine squared is. Cosine squared is 1 minus sine squared, yes? Again, the famous formula. But now sine squared, you know, this is your sine squared. And then you take the common denominator. So this one multiplies itself here, and then you have minus a and a are gone. So cosine squared x is what? B over a plus b. And so we don't need this. And then this implies cosine to the power of 4 is b to the power of 2, a plus b to the power of 2. Agree? Am I right? So this is now in your hand. Did I achieve my goal? My goal was to get rid of x in favor of a and b. I was able to do that. So now I start, the left hand side is equal to, b is just b, multiplied by, instead of sine to the power of 4, I can write this. Yes? And then plus a times cosine to the power of 4 is a times b squared, a plus b to the power of 2. And then what happens? I multiply this here, it becomes a squared b over a plus b to the power of 2, ab squared divided by a plus b to the power of 2, but I am lucky, the denominators are the same. So I just write this, and I add these two. So it becomes a squared b plus ab squared. But can I continue? Yes, because I haven't reached to the other side, but this is very easy now. I factor ab out. From here a is left, from here b is left, and then I have a plus b to the power of 2 in the denominator. And this one of them and one of them are cancelled, and I reach to the right hand side. Yes? So that was the proof. So, but you need to think logically. So this is the nature. You see, is there anything that you really think is above your knowledge? But you have to be creative. So that is the nature of those problems. So now how many volunteers are there? Yes, Martin, good, Martin. Yeah, just join the exam and leave the exam session. Is it stressful? Okay, but if you want to join, send me an email, because I want to know that if we have enough volunteer, we can set it up. Otherwise, we will be disturbing the school. Okay. I didn't find time to motivate you, but I could show you that. By the way, you know that if you can crack that exam, but of course it's extremely hard. But then, of course, you can immediately go to best universities in the world. Yes, you know that this is a local exam, and then I have supposed to send your papers to the center. They will correct you, and if you reach the threshold, which is not that above, so then you will compete in the national level, and after that, they will choose 6 people for the international. This year it is Norway, so they will take you to Norway to meet other students at your age that actually crack math problems, and then you will start competing. Okay, and that's called International Mathematics Olympiad. Okay, it's IMO for short. I will introduce some part of it still. I haven't given up yet, but tomorrow I will probably. Tomorrow, do we have lessons? Do we have lessons tomorrow? No, the day after tomorrow. Yes. Tomorrow is I have only lessons with math specialization. Yes. No, so.
I don't think we have any lessons tomorrow.
Tomorrow is why?
Well, no, because Wednesdays.
Aha,
we
it's
don't
Wednesday.
have math
But I
at
remember.
all.
Okay. So on Thursday, I will try to prepare something for you to show it here. Might we get motivated? But the competition, constructive competition, is probably a very nice thing. Yes. Yeah. So it's good. So thank you very much. But if you are determined right now, please do not forget to send me an email.